This is going to be called the definite integral in the fundamental theorem of calculus. The definite integral provides a number. In 5.4, we'll talk about what that number is, where it comes from, what does it mean. But this is actually doing a calculation of the integral itself. And it says this: f is a continuous function from a to b. That means it can be continuous outside of a and b, but has to be continuous inside. And if f is any antiderivative of little f, then the integral from a to b, that's the way we say it, from a to b of f of x dx is the antiderivative evaluated at b, subtract the antiderivative evaluated at a. So this big F is the antiderivative. So this is the antiderivative evaluated at b. And then you're going to subtract the same thing, the antiderivative. I can't do that this morning. Evaluated at a. In other words, you're going to evaluate the two resulting functions. And what we normally, if this is the upper value and this is the lower value, this is going to be the upper, subtract the lower when you're doing the evaluation. So here we go. Now we know that we can integrate term by term. That's another direction to go. I tend not to do this piece of it right here. I tend to leave it as one piece so I don't have double things to evaluate. So if I'm looking at this particular problem right here, I do what I normally do. I just find the antiderivative. So what's the antiderivative of 4 minus 2x to the minus 3? 4x minus 2x to the negative 2, right, over negative 2. Now we don't need the plus, we won't need the plus c. I'll explain to you why we don't need that. Then we normally would say this is evaluated at evaluated from 1 to 4. So that's going to be my evaluation. I'm going to clean this up. I'm going to put parentheses. This is 4x plus 1 over x squared, minus and a minus is a plus. 2 divide 2 is going to give me a 1. The 2's go out. And this is going to be evaluated from 1 to 4. Now, if you were to look at some people, what they do is they do the 4x from 1 to 4. Then they add the 1 over x squared from 1 to 4. I'd rather do the whole thing at 4 and then subtract the whole thing at 1. So what would this be? Well, if x equals 4, this would be 4 times 4 plus 1 over 4 squared, subtract 4 times 1, so it's upper minus lower, plus 1 over 1 squared. Which is 16 plus 1 over 16, subtract 4 plus 1, which is 16 plus 1 over 16, minus 4 plus 1 is 5, which is 16 plus 1 over 16 minus 5, which is going to be 11 and 1 over 16. Now, in the next section, that's going to have some meaning for us. That's all that is. That's really all that is. You look at the A's and B's, they're just going to be numbers, and you're going to put numbers in once you do the antiderivative. Now, I said to you, and I'm going to put a line down here, you don't have to worry about the C, and then you're going to say, well, why is that? Well, if I looked at the two antiderivatives, right, if I said, okay, the antiderivative 4x minus, or essentially plus 1 over x squared plus c. Say, okay, we'll have the c. Well, if I'm doing upper minus lower, this is going to be evaluated from 1 to 4. So this is going to be 4 times 4 plus 1 over 4 squared plus c minus 4 times 1 plus 1 over 1 squared plus c. What's going to happen to the two c's? They cancel out. So with the definite integral, the c is there, but it adds a 0. So what would you end up with? The same thing, 16 plus 1 over 16 plus c minus 4 plus 1 plus c, or 16 plus 1 over 16 plus c minus, this is a 5, minus c, and then the two c's cancel out, add 0. So you would end up with 11 and 1 over 16. So that's why I don't need to worry about the c. You won't see me put the c in when I'm doing a definite integral, because they're going to end up adding to 0.